We have things like our sponsors, vendors, Brick Stuff, Boo Wiz. We also have SBrick and many, many more. So many more that I'm not going to talk about any of the third-party stuff today. We are just going to focus on Lego. And to begin with that, we're going to talk briefly about the history of Mindstorms. So there were 4 flagship products over the course of Mindstorms history. We started with the RCX in 1998. We got the NXT in 2006, which was rebooted in 2009, the EV3 in 2013, and the Robot Inventor in 2020. As some of you know, this line is now retired as of recently and dead. But it's not really dead. Obviously, all of these things are still out there and available and usable. Now, these are the flagship products up above. But at the same time in this history, Lego was doing a lot of stuff that was not Mindstorms. In the beginning, as early as 1986, they had at least semi-programmable things. And then there was this big gap, and today we have Powered Up, and WeDo, and Boost. And you might be wondering what happened there in the center. And it was a few things. First of all, that's right when Lego had its big financial crisis. There was a lot of over-innovating happening. They were putting out too much new stuff, exploring into things that they didn't really need to. So they cut production on a lot of that. Additionally, the power functions, even though it's not programmable, came out right there in the middle. And between the NXT and the power functions, you could do pretty much anything you wanted in terms of enhancing your models. To be fair, WeDo came out in 2009, and WeDo partnered, is a sister product with Power Functions, which did allow Power Functions to be programmed. Let's talk about each one specifically. So starting with the RCX. It's a terrible picture, isn't it? That's directly from Lego's website. That's how much of a dinosaur this guy is. But a lot of people still use RCX, so I don't want to turn anybody off to it. It's just not the most ideal product today for people just getting into things. This guy came with a light sensor, a pair of touch sensors, and a pair of motors. These are 9-volt, very brick-based components. And the bot itself was kind of funky colors, both brick and Technic-based. Then, when we got to the NXT, or Next Technology 1.0, we had a much more Technic-based humanoid robot with some big, big differences, right? We've got an LCD screen now. The components that were included with this were 3 servo motors, a touch sensor, a sound sensor, a light sensor, and an ultrasonic distance sensor. And then when this thing got an upgrade to 2.0, got an even beefier robot, and the components included here had a big change. Instead of just a light sensor, we got a color sensor. So not only could it tell the difference between light and dark, it can now register the difference between up to 5 different colors. And this is one of the things that I use the most in my builds. If you were paying close attention, you might have noticed another change. And that is, oh, that's the laser. Instead of a sound, we had a sound sensor before, and instead of a sound sensor, we now have 2 touch sensors, and that's because, quite frankly, the sound sensor is pretty, can't really do a lot with it. It's much more useful to have a pair of touch sensors. Then we got the EV3. This guy could be called Spike, this spiky mohawk. You can see kind of a common theme here. We've got a kind of humanoid robot with grays and whites with a standout color. We went from orange to red. There's a lot of similar components here, but you might notice one big difference, and that is that instead of an ultrasonic distance sensor, we have an infrared proximity sensor, and we got a remote control so that you could control your bot remotely. At the same time that this was out, Lego Education put out a different product, which included a gyro sensor and a true ultrasonic distance sensor. So those components became available. And then I should say, like the NXT had 3 of those large servo motors. In this case, we have 2 and then a smaller servo motor. Then we got Spike Prime and Robot Inventor. This is the first time that LEGO put out products that were essentially the same, education and at home, with different names. So before you had NXT and Education NXT, same with the EV3. Now we have Spike Prime and Robot Inventor. And you can tell which one's for schools, right? Little guys, we've got a both brick and Technic-based bot, very colorful, exciting, and then we followed the same theme as these other guys with the humanoid robot standout color is teal this time. Now, to be fair, I say it's a humanoid robot. This is obviously the base model that comes in the set, and there are sub-models, instructions for additional things that are cats and guitars and whatever else. As far as components go, we have some massive differences between the NXT and EV3 and these guys. We no longer have our LCD screen. We have a 5x5 light grid matrix. Everything is really conveniently squared off, conveniently sized and shaped. For Spike, we've got a pair of, I always get mixed up on the medium to large motors, but we've got some smaller motors and one bigger motor. We have a color sensor, an ultrasonic distance sensor, and now instead of a touch sensor, we have a touch force sensor. So you can actually tell how much you're pressing the button, how hard you're pressing the button. Although it only shows one motor here for the Robot Inventor, it actually comes with 3 motors of that same size. So all of the smaller, none of the bigger ones, and then unfortunately we lost that touch sensor for the Robot Inventor at home. I'd like to briefly mention, even though it's not one of those flagship products, Spike Essential. This is for the little guys. As you can see, it's totally brick-based, but it has some really cool components. And we have a little tiny brain. We've lost our screen completely, no 5x5 light grid matrix, so we have a 3x3 colored light grid matrix, super fun. And same color sensor, but 2 little itty-bitty baby motors. And when we're done, I'll let you come up and check this guy out. I made this little robot using that set, so it allows you to do some pretty cool condensed things. Now, I should also mention Boost and Powered Up, because they are available to you right now, even though they are not Mindstorms' flagship products. They're still robotics. And you probably have, how many people have the grand piano or the lighthouse at home? These are more geared towards AFOLs, right? And then Boost, the weird cousin. It's not Mindstorms. It's not part of education. It's kind of like at-home education. It's just the weird cousin. But it had some interesting components. So we've got a large move hub, which includes 2 motors built into it, a color distance sensor, and then a medium motor. And those are all really brick-based, as you can see, while everything else has been pretty Technic-based. As far as the other guys go, the grand piano has a standard hub, a medium motor, and then we borrowed the distance sensor from, or the motion sensor from WeDo. The new trains, if you're into trains, have that same hub. They've got a new remote that's a little bit more customizable than before, and then a train motor. And these will probably, if you use power functions all, they'll look really similar, because essentially they're the same thing with updated cords. And then finally, the lighthouse, we've got some new lights, medium motor, and this is the only example of the powered up stuff where you have a box, a battery box, that is set it and forget it. Push the button and walk away. Everything else within this line has to be programmed. So this is the one thing where you can push a button and it goes and you can leave it alone. Now our big question, which system is best? What should you buy, right? I'm gonna look at 5 things: hardware and power, programming, flexibility, longevity, and cost and availability. What do I mean by these things? Obviously, with hardware and power, I want to know, things blended together apparently. What elements are offered, right? What is included in the set that is going to work for my particular project, obviously. With programming, not only do I want to know how easy it's going to be to understand the software, I want to know, is it going to hold up in the future? And is it going to work between different builds? And really, that's what flexibility is. What capabilities make it easy to use between builds? And is that programming going to stand the test of time? Yeah, longevity. How's it going to stand the test of time? Between those three, what I really mean is how recyclable is it? On here, things are kind of blended together. And then, of course, cost and availability. How much am I going to have to fork out, right? Everybody wants to know that. So we're going to look at these contenders. As I said, the RCX, kind of a dinosaur, not really a fair comparison, so we're going to kick him out. We're going to look at the NXT, the EV3, the Robot Inventor, or Spike, and Boost, okay? Or Powered Up, and more so Powered Up than Boost. First, let's look at the brains. So the NXT had 3 motor ports, 4 sensor ports, an LCD screen, produced sound, and has this really wonderful capability where via Bluetooth, you can connect up to 3 subordinate bricks to a master brain. And that's the magic behind everything that I build, because I can't make a pinball machine without using 4 of those. So that's how it works. The EV3 takes it up a notch. Instead of 3 motor ports, we've got 4 motor ports. It lights up, it's got USB connectivity, it's got Wi-Fi connectivity, and it has that same fancy Bluetooth trick, but it can also do it corded and not just Bluetooth. Both of these guys use the same cable, which is a telephone-style connector. They come in little tiny sizes, big long sizes, and it's a little bit firm and difficult to put in build. So that's something to consider. I kind of made a stark line here because, of course, there are a lot of similarities on that end and a lot of similarities on that end. So that's why we have a thicker line there. With the Robot Inventor and Spike Prime, you've got an onboard gyro sensor, you've got your 5x5 light grid matrix, and there are 6 in-out ports. And when this came out, it was like, what the heck, man? That's not cool. With the EV3, I had 8 ports. Now I only have 6. A lot of people were upset about this, but the key thing to remember here is these are in-out ports. That means I could have 6 sensors. I could have 6 motors, or any combination in between. So really, in that regard, it has more flexibility than the EV3 or the NXT. And of course, like I said, you've got that onboard gyro sensor. With the EV3, you had to have an external one, so it takes away that need. Your gyro sensor is also an accelerometer, which is kind of cool because it can detect if you drop it, if you shake it. So think about, there's all of these different possibilities of things that you can do with what you have in each of these models. SD card, so with the EV3, you can add an SD card to expand the memory. SD card aside, the Robot Inventor has less overall memory. So if you're trying to build big projects with big programs, again, something to consider. And I'll get back to that cord in a second. Everybody else. So the Boost and the Powered Up stuff have a couple of in-out ports to them. Like I said, the Boost has a couple of internal motors. No longer producing sound. Your sound comes from your phone or whatever you're using to program them. These guys, as I said, are app controlled. You program them on the app, you can run them on the app. And back to that cord. So now we have a totally different connector system. These cords are, the end connector's easy to plug in and pull out. It's very flexible, it's thin, it fits in more spaces. It's about 10 inches long and stuck to the motors and sensors. So that's what you're limited to. So for people like me who build arcade machines, it's really difficult to get by with that. unless you're doing something super creative. So I would challenge people, if they want to go that route, you could have data transfer with color sensors and motors, right? You could bypass the cords. But it will definitely take some creativity to make that happen. And, oh yeah, the external remote can do power up to, or control up to 5 of those hubs that I mentioned before at one time. You can switch between them. So that's kind of cool. A quick note on gears and motors. So there are some gearheads in here that are going to be like, Bre, that's not quite exactly how it is. But this is kind of the for dummies version. So with gearing, generally speaking, more torque equals less speed and vice versa. There's something called a gear reduction, where you take a small gear to drive a larger gear, and that creates a system that is stronger but not necessarily as fast. And then of course you have the opposite, where you gear up and you create a system that is faster but not necessarily as strong. This is the inside of an NXT motor. So you can see there's lots of gears, lots of things going on in there. That's partially what facilitates that. There's also a rotation sensor in there. And that allows you to communicate with that motor and tell it what you want it to do. Turn this many degrees, go this many rotations. So that's how you're communicating with that servo motor. Before I move on, I'd like to say that a lot of the information I got on the next page comes from this website, philohome.com. It's designed by a guy named Philippe Urbain, aka Philo. He's super smart, and he breaks these things down to the nitty-gritty. So if you're somebody that likes numbers and specs, I would highly recommend going to that site to learn more about it. Got your picture? Okay. All right, so some people don't know what a servo motor is. So here's the definition from Wikipedia. A servo motor is a rotary actuator or linear actuator that allows for precise control of angular or linear position, velocity, and acceleration. It consists of a suitable motor coupled to a sensor for position feedback. So that's what I was talking about with that rotation sensor inside the motor. That's how they communicate. And a lot of these guys that I'm showing you are servo motors. That's how they work. So we'll start with the NXT. I don't know why things are kind of overlapping. Hopefully that doesn't get bad later. So with this guy, slow rotation, higher torque. Now I should say that when I'm talking about this, it might seem to get a little confusing because there is an equilibrium there, right? It doesn't necessarily mean you're always going to have high torque, you're always going to have low speed and vice versa. There's a bit of equilibrium. So, but in the case of the NXT, slow rotation, high torque, and the efficiency of that is average. And what do I mean by efficiency? That's how well it's working with the power that you're giving it, how much power it's using, okay? The EV3 is really, really similar. That big motor is almost the same as the NXT, but it's actually even slightly less efficient than the NXT. The smaller motor has overall generally less torque. For the Robot Inventor and Spike Prime, you've got pretty slow rotation, lower torque than in comparison to the other. That's the other thing. These are in comparison to each other across the board. So out of all of these motors, we have generally slower rotation, low torque, low efficiency, but these have absolute positioning, which means that there is a zero marker on these motors, which allows you to always return back to 0 point. With the other guys, if you start a program anywhere, like when you start, anywhere within that motor's rotation is 0. With the newer guys, there's actually a specific 0 on the motor, which allows for more precise control and accurate control. And then out of all of these, the most powerful is going to be that larger motor. So out of all of the motors that I talk about, that one is the most powerful. Everybody else generally has mid-range speed, mid-range to high torque. In general, they're pretty low efficiency, but they have great attachments, so that's nice. These guys over here have terrible attachments, but these guys have much better attachments. There is one exception to the rule there in terms of rotation speed and torque. It's the opposite, so pretty high rotation speed on that train motor. And then out of all of those guys, the one, let's see, oh, I do have this laser. That one is the most powerful out of those. You would think that this guy would be, but these are basically the same motor in different packaging. There's really no difference between them. So if you have them, or if you're thinking of buying them, that's something to consider. Okay, moving on. We've got sensors here. So these are the NXT sensors I mentioned before. As I said, the sound sensor is pretty... Somebody might find something really cool to do with it, but I have yet to find anything really cool to do with it. Overall, these are pretty decent at transferring data, and they do have the occasional issues. For example, say you're displaying in a large expo hall. You've been building this thing at home and testing it at home, and it works really well, and then you get to the expo hall and it doesn't want to work anymore. That's because all of that ambient light is really tough on the sensors. So you can recalibrate them when you get to the expo hall. You can build shrouds around them. But yeah, so that's something to consider because with these guys, that really affects them. For the EV3, they are overall faster, more precise, and more accurate than the NXTs. And the color sensor has an added color. So instead of 5, it can tell the difference between 6 colors. On the other side of the aisle, these are very similar to the EV3 in terms of how precise they are and the data transfer. They have better attachments overall. The ultrasonic distance sensor has built-in lights, and I believe they are programmable. And then, as I said, there's that onboard gyro sensor, and that force sensor is not just touch, but force. These other guys to consider, that boost one, color, light, and short range distance. All these are infrared based. You have the We Do motion sensor, and then the multi-directional tilt sensor. This one can have some issues. You might have to be more forceful with your tilt to get it to work. So those are some things to consider there. With power, the NXT and the EV3 both take 6 AA batteries. They both had rechargeable options with their education versions. The NXT has 2 because, as I said, it was rebooted. And the second one is a better lithium-ion battery. With the Robot Inventor and Spike Prime, it's only rechargeable, but it's USB. You have some more flexibility there and options there. And then for the other guys, they all take 6 AA batteries, no rechargeable option, and I wouldn't hold my breath for one coming anytime soon. This is going to look like a lot of text, a lot of words, but don't worry, there will be pretty pictures. The NXT has really limited onboard programming. The proprietary software is called NXTG, but you can use lots of others if you really want to get into that. There are plenty of other options out there if you rather program it in something else. The EV3 is really similar, however, the onboard programming is much better than the NXT. It also is specifically designed to be able to work well with Python, which is used often in the classroom. The Robot Inventor and Spike Prime, you lose your screen, you lose your onboard programming. This program is Scratch-based. What's Scratch? The short of it is that these are puzzle pieces that have to fit together in a certain way. It's a lot more difficult to screw it up. That's basically the bare bones of it. This is also specifically designed to be able to work well with Python. As for the other guys, Boost is awful. Some people might disagree with me, but I don't like it at all. It's very elementary. Powered Up, it gives you a much similar experience to Robot Inventor. It's phone or tablet only in terms of programming, so you can't program it from a computer if you're a computer person. I guess unless you hack it somehow. But your programmable, your device doubles as a remote control. These things can all be found at this website. So this is Lego's website. These guys are retired, no longer supported, but you can still find them and use them if you go here. So I'll let people get their picture. Cool? Okay. Now for the pretty pictures. This is NXTG. This is what it looks like. I'm going to give you a brief overview of each of these. I'm not going to go too in-depth. We can talk about that later. But I built a little tiny snippet of program for each of these and tried to make it as close as I could between them so that you could see the difference. So our program, we are going to wait for a button press, reset the screen. We're going to go forward, turn around, come back, turn around. We're going to play applause, display a smile, and we are going to do that forever. Okay, so that's our program. As far as how NXTG works, this is a picture block-based program. You set the parameters in a little dialog box. So when you click on these guys, it opens a dialog box and you can set the parameters there. You can also get really complicated with all sorts of wires and things, but this is super easy, straightforward program. Your palette is on the side. We've got movement, output, input, flow, equations and variables, advanced. It kind of goes from top to bottom, easiest to most difficult. Colors make sense in that regard. There's also something called My Blocks. And My Blocks are wonderful tools. I can take this snippet of program, select it all, turn it into a My Block. It condenses it so that it takes up less memory on your device, and it declutters your program. This is the EV3 Home Edition. Same program. Wait for button press, go forward, turn around, come back, turn around, play applause, display a smile, and do that forever. Same exact program, but it looks quite a bit different, right? It looks a bit more complicated, but it's really not. All of the parameters are set on the blocks themselves instead of in a dialog box. If you look closely, it's actually really simple and straightforward. As far as our palette goes, we've got output, flow, input, equations and variables, advanced, and My Blocks. So very similar stuff, but instead of being on the left-hand side, it's now tabbed on the bottom. This is the new Robot Inventor. We've got dark mode now. It's kind of cool. Instead of going left to right, we go from top to bottom. Totally different, but we have the same program, right? We're going to wait for it to start. We're going to wait for a button press, go forward, come back, turn around, play applause, display a smile, and do that forever. So same exact program, but top to bottom instead of left to right. All of your parameters, once again, are set on the blocks themselves. So blow it up there for you because it's a little bit small and harder to see. So like the EV3, everything's set on the blocks themselves, and they're more word-based instead of picture-based, so it's pretty easy to follow all of these little phrases. Your palette is now back to the side, and it looks like so much, right? You've got motors, movement, light, sound, events, control, sensors, operators, variables, My Blocks. It seems like so much, but it's really not. It's the same things, but because these are simpler blocks, they're very straightforward phrases, You need more of them to achieve the same thing. So it's not that there's so many more blocks, so many different things that you can do with them. It's just a matter of how simple each of those blocks are. And then this is powered up. Boo. So it's simpler. It's much simpler, but it's not Boost. Boost is worse. This actually is kind of like a baby version of EV3, right? We don't have our screen anymore, but we do have an onboard tilt sensor. So we're going to wait for a tilt. We're going to go forward, turn around, come back, turn around, play a sound. We can't display a smile. And we can't do it forever, so we're going to do it for 3 times. So fairly similar program, but with some key differences there. The palette has moved back down to the bottom. Flow, input, move, remote, output, equations, and my blocks. And this is kind of this like hybrid between EV3 and the kind of scratch-based stuff, right? These are puzzle pieces that fit together a certain way, so it's much more difficult to screw it up. All right. Moving on, flexibility. So the NXT has various chord lengths. A multiplexer is possible. That's available to you. A multiplexer is something that you can plug into a port, a sensor port, and it extends the number of ports. And I have one up here so that you can see it. I believe it's 5, 6 ports that it adds to your robot or your whatever you're building. And then there's that daisy chaining that I talked about. The EV3, same stuff, takes it up a notch. It's got that expandable storage and it's backwards compatible. What does that mean? Well, the EV3 can run all of your NXT sensors and motors. So if you already have NXT and you want to upgrade, you don't have to get rid of all of those. You can still use them with the EV3. The same is not necessarily true in reverse. The NXT cannot use the sensors for the EV3. On the other side of the aisle, the Robot Inventor and Spike Prime, as I said, their ports are all in-out. Everything's very conveniently sized and shaped. There's lots of attachment points. The downside is it's not backwards compatible. Without some external hacks, you cannot run any of the NXT, EV3, power function stuff with those guys. And then with everything else, they're smaller, so they fit into more spaces. There's lots of interchangeable components. You can switch between the different platforms, so like Boost, Powered Up, you can switch between them to some degree. And there are no Lego extenders, splitters, or converters. So you can't make that 10 inches any longer unless you go third party. As for longevity, the NXT reigned for 7 years. The hardware can develop wear and tear issues over time. Your screen can go out, your sound can go out. If you're handy, you can fix those things yourself. I have these, I have a million of these, and most of them I've never had a problem with ever. It's like they're new. So they do last a long time if you give them care. I'm not really sure why things are getting cut off. The EV3, 7+ years. I say 7+ because it's still used today in First Lego League. There are still some of these items sold from Lego Education, even though it is retired. Just like with the NXT, with some care, it all functions well today. Software is still totally usable. Oh, that's what that said, software is still totally usable. The only thing I wouldn't recommend with the EV3 is putting the brain in a hot car, because I did that once, and the screen cracked really bad. So maybe don't put it in a hot car. But other than that, the hardware is great. It works long time. With the Robot Inventor, only lasted 2 years before they retired the line. It doesn't sound great, but Spike lives on, and it's still doing fine. It's yet to be seen how this is going to do down the road, but I would imagine that it would continue to handle things well. And then, of course, everything else, yet to be seen how this is going to work down the road. However, there's a big thing to consider here. These are all app-based, like I said, on your phone or your tablet. Let's say Lego decides to stop supporting them, which is the case with these guys. So software retired, you can still use it on the computer. However, Lego just took the applications for like remote control off the app stores. Imagine if they did that with these. You no longer have any way to program those. So that is something to consider. I don't imagine that being a problem anytime soon, but just something to consider. Finally, we're on to cost. This is a big thing. Again, gonna look like a lot of text, but pretty pictures are coming. You can find these guys on eBay and BrickLink. If you're willing to wait, you can get some great deals, and it's easy to piecemeal. The same goes for the EV3, maybe even a little bit more availability. The Robot Inventor, because it retired so quickly, it's very hard to find. Lego Education is not just for education people, though. Anybody can go to Lego Education and buy these products. So you can go and get Spike from Lego Education. However, these are really difficult and expensive to piecemeal. Everybody else, you can find them all over. Boost is recently retired as well, but I've found it still in department stores for about 130 bucks. Once again, a little bit difficult to piecemeal. So if I wanted 20 color sensors, for example, it's a bit more difficult to get them this way. So for fun, about 8 months ago, I went and looked for the best average prices for these guys. So this is what you're looking at for the NXT, the EV3, their power sources, and then for fun, I added in the multiplexer I talked about, additional cord lengths, and then this is really cool. Power Functions has a 9-volt to Power Functions conversion cable, and then Lego Education put out a 9-volt to NXT conversion cable. You combine those together, you can now run all of your power functions on your NXT or EV3. So that's pretty cool. Everybody else, so these are all those guys and all of those brains and their power and their sensors and their motors and the remote and the lights. And to be fair, I included splitters, extenders, converters. And I don't know what this looks like to you, but this is what it looks like to me. It is very, very, very expensive to go this route. I'm not trying to detract you, but I'm just letting you know it is expensive to go with the newer stuff. We are all doing different things, right? I've used a lot of robots here, a lot of humanoid robots to talk about this. And I build arcade machines. I've talked about that. You're all going to be building something totally different. So you need to look at this, at how each of these products is going to work for you in your specific situation. But one last time, we are going to even the playing field. Okay, we're going to go with the humanoid robot. And this little guy is going to have 3 servo motors, a color sensor, a distance sensor, a touch sensor, and a gyro sensor. This is the one robot that all of those products can achieve. Okay? And here's what the cost is. The NXT is going to cost you $50 to $100 to achieve that robot. The EV3 is going to cost you $100 to $200. The Robot Inventor, Spike Prime, is going to cost you $400. And then everybody else, it's not really fair. You can do it a lot of different ways, and it's complicated. It gets complicated, it varies, so it's not the best comparison, but I thought you guys might appreciate the differences there. So, in summary, the NXT and the EV3 have a medium difficulty to learn. The NXT is best for medium to large projects with minimal funds. The EV3 is best for medium to large projects with average funds. On the other side of the aisle, both of these guys, all of these guys are very, very easy to learn in terms of programming. The Robot Inventor is best for small to medium projects with substantial funds. Everybody else is best for small projects with average to substantial funds. That's kind of like a broad idea of what you're looking at for cost. So to Mindstorms or not to Mindstorms, obviously, in my opinion, Lego's the best way to go. Like I said, there are others out there, but I think you just can't really beat these guys in terms of what they offer. Well, apparently we're just going to go right past that. But basically, you're all going to have to determine what matters most to you in terms of the level of interactivity with the public, to time, to cost, to level of recyclability between this project and that project. But for me, what's most important is my ability to wow the crowd and interact with people, because that's what I love. Being staff is kind of hard because I don't get to do that interactivity stuff. But that's what's most important to me. You're going to have to determine what's most important to you, and I hope that what I've provided today will help you make that decision. With that, I will take questions. I have a little bit of time for questions. And then I do have some things up here. These are examples of pretty much everything I've talked about, so you can pick them up and play with them. And I'll get that guy started so you can play with him. So, any questions?
Hey everyone, my name's Derek, and I am supposed to be the moderator for this. Sorry I'm late, but I was in the Master Build Finals. You all know how it is. You all know how it is when you're participating in that and you get late, you know. Anyway, I have some questions from the online participants. I'm going to ask those first. Other folks with questions, you can come up. You can either get in line now, or if you don't think there's going to be a huge line, just wait till I'm done. I've got 2 or 3 questions to ask from folks online. And then just come on up, ask the questions using this mic here. That way the folks who are online can hear. Yes, you can probably shout, but they still won't be able to hear you if you don't come up and use this mic. So, with that said, going back to when you were talking about the comparisons between the different components. Question from Bruno Dilala. Does the master-slave capability extend beyond the first NXT generation shown? Does that question make sense at this point in time?
Kind of, maybe. So is he asking, does it just work with the NXT? So I did say that it works with the EV3 too. So say it one more time.
Does the master-slave capability extend beyond the first NXT generation shown?
Oh, does it work for the first and second generation of the NXT?
Yes.
Yes. Sorry.
Okay, there we go. Short and sweet. Next question from Sue Booth. Is there Apple/Mac software, is there Apple/Mac-based programming software available for NXT and the other earlier Mindstorm systems?
Yes.
Okay.
Yes, if you go to that website, you can find both Apple-based and Windows-based software.
And to follow that up, I'll just, so everyone else gets to hear this part, Justin Clark pitched in on that and pointed out also that NQC, not quite C, is an unofficial programming language for the NXT system and works with both Windows and Mac OS X, and the graphical version for Macs is called Mac NQC. So that's actually all I've got from online. Anyone else who has questions, please come on up and use this mic. Thanks.
I'll do my best, by the way. I'm not sure if I can answer all of the questions.
So you talked about the power cords from 9 volt going through all the different iterations of Mindstorms. Could you say that again and slow it down for us old folks?
Oh, sorry. Okay, so don't run away. I need you. Okay, so how can you explain more what you're looking for?
You showed the 9 volt patch cord that goes to the plug-in 9 volt.
The power functions to 9 volt thing?
Right.
Yeah.
And you'd said you could go from 9 volt, essentially, that plugs into the wall, all the way through the newest generation of things. And I was missing how you got there.
Okay, so the converter cable can take 9-volt products and convert them to work with the NXT or the EV3. With the new stuff, the Spike and Robot Inventor, that they don't have that capability unless you use that third party. So I guess really it depends on whether or not you want to go third party or you're a purist. I'm a purist. So that's why I was kind of focusing on the options that Lego does provide, but that works for the older products, the newer products. They do have converter cables.
So you were talking primarily with the EV3.
The
That's
NXT
good,
and
'cause I have
EV3.
that.
Yeah, both the NXT and EV3.
Okay, thank you.
So I'm wondering, because there's so many generations and iterations, if there's any benefit to going outside the Lego ecosystem to like Arduino?
Yeah. I guess so. Yes. So honestly, I don't know much about those systems. As I said at the beginning, I'm not super smart. I am not a wizard at any of this. This was super easy for me to pick up and run with. I know a lot of people like those things, and I wouldn't detract anybody from doing them. But again, I'm a purist.
All right, thanks.
Sorry.
That was essentially my question too. So my follow-up is, do you have a sense of how the community views using other kinds of electronic systems with Lego, like Arduino or Raspberry Pi, whether it's lighting or other kinds of stuff you can buy through Adafruit and other places? Is that acceptable, or is that frowned upon, or is it very?
You know, more and more people are doing stuff. I mean, like I said, we've got brick stuff, right? We've got Boo-Is. A lot of people are using those, and they're not purist products. I joke about being a purist and like steering people in that direction, but I think we're all creators and happy to see whatever you make, whatever you use doing it.
Cool, thanks.
I missed the very beginning of the talk, so forgive me if this was addressed. But what's the main difference between the We or the like the We Do Education Hub and like the Powered Up Hub, and then the Spike Prime Hub and the Robot Inventor Hub? Because from what I've seen, they're very similar, but I can't really tell exactly how they're different.
Really, they're not. Like the Spike and Robot Inventor are really, really similar products. They're essentially the same product, but the platforms, the software platforms, are a bit different, and it's just based off of like how they're used in school, really, and the aims there. But they can use it used interchangeably. Like they're essentially the same product.
That's kind of what it seemed like to me. Just I heard software differences, but yeah, I guess that was really all I was curious about. Thank you.
They load each other's firmware. It's the same hardware.
Yes, yes.
Okay, another online question from Elam Birnbaum. Is there a way to just plug any of the power functions into an outlet so you don't have to worry about batteries? Obviously not an option for mobile builds, but if you were doing something like a static display like your pinballs, is there some third-party hack that allows you to use wall power?
It's a great question. So I talked about for the NXT and EV3, they had rechargeable batteries. You can just plug those into a wall and leave them plugged in and walk away from your MOC. I wouldn't encourage doing that a lot because that's not really healthy for the battery, but you can totally do that. That's an option. And I don't really do it, but I would guess that with the USB connection, you could do the same thing with the Robot Inventor or Spike Prime. Just plug it in USB and continue to run it. If you've got a long enough cable, this one's pretty short. Oh. See, I'm not very smart. Apparently what she said is she Okay, so apparently for those that are virtual, it's been tried before and it didn't work.
Well, it depends if you're loading the battery very much. Like if you're writing lightweight stuff, it'll run, right? Sorry. Right. So yeah, if you're running a lot of motors, like the what was the Spike Prime thing that was the little carnival over there, she's running a lot of motors off of one Spike Prime. She's finding that even plugged in, it runs down.
Yeah.
But I have another mock where it was just occasionally running motors and running some sensors, and they're pretty much indefinitely. So it depends on the load you're putting on it.
It's a good question.
I had a quick question about sound generation for the different robots. I
Mhm.
know RCX could do just beeps, and then NXT can do like some waveforms. I don't know if what the other platforms can do, whether it's like the just a short library, or are there custom sounds you can add to any of those?
That's a really good question. Yeah, so each of them do have a sound library with blocks that you can plug into your program with various sounds. The earlier you go, like NXT is kind of tinny, like the sound quality isn't great. For the newer stuff, all of the sound comes out of your device, your handheld device, so your phone or your tablet. They don't produce sound at all.
Oh, okay,
But they
got it.
do have sound in the program, so you can still play sound just through the program. And then there is a possibility, like with the NXT and EV3, to record your own sound and play your own recorded sound. However, that does take up a lot of memory, and it can run away from you pretty quick.
So you would say the EV3 is the last one where the sound comes out of the Lego brick itself?
The Robot Inventor and Spike Prime do produce sound as well. It's just the brand new stuff, the smaller stuff.
Oh
that
yeah,
doesn't.
powered up doesn't have.
Yeah.
Okay.
Yep.
All right. Thanks.
I'm being told to cut out. We're up against a break. Well, then you can leave. Last question. If you have any more, please come see me. I'm happy to show you things, talk to you, whatever.
So technology is by nature seems to be very short-lived. 7 years seems to be a long time for any technology to live. Does it seem like Lego, having canceled everything before, is at some point in time going to listen to the fan base and say, you know, we ought to make something that's going to last, it's going to be expandable, that's not going to be so changeable and so non-interchangeable for the dumb people like myself who just want something that in 20 years I'm still going to be able to plug in and it works.
I wish I could speak for Lego. I got to be part of a focus group with Lego when Spike came out, and I talked to them a lot about that stuff and didn't get much in response. Yeah, it's hard to say what they're gonna do. Like I said, all of the stuff, the early stuff is still totally usable today. I mean, it's not, like the RCX is not necessarily the most intuitive, but at this point, the easiest thing to use, but it's still totally usable and the software's out there. It's just not being updated or upgraded by Lego. So, yeah. Does that answer your question at all?
It sounds like it probably would have been
Yeah.
answer, yeah. Thank you very much. Very good presentation.
Thank you. Thank you, yeah. Appreciate it.